start. So recording is okay. So good evening, good afternoon, and welcome to the session for Graph Neural Network. My name is Ankur Pachori, and I will be teaching the course for Graph Neural Network. Okay. So as the count is more, there might be, as of now, there's only one section. Okay. But later a new section might be created and somebody else might be taking that section. Okay, I think the count is more than 200 as of now. Okay, so in the meanwhile, I will have till that new faculty is assigned, I will be handling both the sections. Okay, so let us begin with this module. Let us begin with this course, and first few slides I have taken it from the course handout. I think I have not uploaded the course handout into the portal, so I will do it. I will do. I will upload the course handout most probably by today evening. Okay, and then you will have an access. So these few slides I have taken from the course handout only. So what all are the objective? So first of all, we will be dealing with the graph neural network. So we'll be applying the neural network technique on a graph database or graph data. So, and most of the time we will be talking about the classification activity using the classification activity on a graph using the neural network. Okay, so first of all, you will learn how to extract out meaningful information from the graph. Then the second, how to apply a neural network on a graph. Then third, to learn how to apply deep learning model on a graph data. And fourth, to learn how to use the graph neural network for a specific application, such as web, social network, natural language processing, computer vision, drug development, and many more. We won't be able to cover all of the applications as mentioned over here, okay, because they themselves is a require sufficient amount of time, okay, but we'll try to cover as maximum as possible. There are few textbooks which are available. Okay, the first and the primary is Graph Neural Network Foundation, Frontiers and Application. Okay, that is a Springer book. The second is the Hamiltonian Graph Representation Learning, and third is the Graph Learning on a Deep Learning on a Graph. Okay, soft version of all the three is available on internet. Uh, Last is I think almost free. Okay, but first two you might they are not directly available, but somehow using some technique we can you can have an e-version. The physical copy of this book is costly. Okay, it's around 7,000 or 8,000 or I think more. Okay, so not all topics are covered in one textbook, and one thing more, all of the three which are mentioned, the first two are not a book, although they are mentioned under the heading of book, but they're not book. They are the collection of survey papers. Okay, so they themselves are the survey papers which talks about many things in a concise manner. So not all the topics will be covered in one textbook or a reference book. So we will be using those research papers to cover most of the other topic, but whichever I'll be using, I'll be first of all, I'll be putting up the reference of that paper, the detail about the paper which I'm using, and I will also, if you want, I can also provide those research papers to you. Okay. So sharing of research papers doesn't comes under the Copyright Act. So I think those can be shared. Most of the content are theoretical, but we will be covering their practical applications also. Okay. There are a few reference books. So neural network, this is a very old book. Okay. So neural network fundamental with graphs, algorithm and application. That is a book of neural network, but that is a very old, and that just covers the basic. Okay, for the neural network. And the second is the social media mining book. Okay, that covers mostly the theoretical or the initial part of the content. Uh, the evaluation scheme, the EC1, EC2, and EC3. EC1 comprises of 30%, EC2 comprises of 30%, and EC3 comprises of 40%. So quizzes and assignment dates will be announced on the portal. And most of the time, I don't think we have, until unless some urgency happen, we will not be deviating away from the mentioned date. Okay, 99.9% times we will follow the schedule which will be announced to you. Okay, so quizzes will be available for I think 1 day. Okay, but the duration for the quiz will be 15 minutes. So although it is available for 1 day, but you all have to finish the quiz within 15 minutes of availability. Okay, you open accessibility. So once you access the quiz, you'll have to finish it in 15 minutes. And assignment will be available for 15 days. You can, that will be a group assignment. You can upload and that will be handwritten. Okay, or it most of the time it no, not handwritten. This is not a mathematics. Sorry, this will not be handwritten. There will be some programming exercises. Okay, so you'll have to code it. You'll have to submit the program as well for the verification. Okay, so your code has to be executable. Your code has to be working while submitting the assignment so that the same can be verified at the time of evaluation. Okay, I request plagiarism not allowed, copy not allowed. Okay, so all the copy cases, all the unfair means will be dealt in the way that both of them. So if we found that two assignments are exactly copied, then both of them will be marked as 0. Okay, so it's not the case that I'm not going to check who copied from whom. Both of them will be graded as 0. Uh, the few requests, I think this I have already requested in the orientation session as well. You all are working professionals, so you might be a habit of writing good mails. Okay, so I request the same. You need to follow the email etiquettes. Okay, because the person to whom you will be writing will be my operation team, it will be my TA, and they all are humans. So I request you to follow the email etiquettes. The second, if you please, I request you to post the individual queries. Do not post the query by keeping many persons in the CC. And if someone replies, if someone sends you, then reply to all is not desirable until unless it is unavoidable. But the most important thing for you is you need to build up a habit of reading the research papers or book. Okay, although the book means here the book will be the editors or the survey papers. So again, somehow you'll have to build up a constant habit of reading the research papers. Reading a research paper is slightly different from reading a book because books are descriptive, whereas the research papers are concise. Okay, so if you feel that any extra information you require from the research papers, it may end up that you may find out a full new paper to find or to extract out the meaning of a particular sentence. So if you want to find out a meaning of a particular sentence, or if you want to know more about a particular sentence, it may be possible that you'll have to end up reading a whole new research paper. Okay, because the content of the research papers are very concise. They used to just make the statement without the explanation. So most of the time, the explanation is missing. So you'll have to put, or you'll have to build up a habit of getting the solution from internet or from me, or to find out a meaning. Okay, and uh, it is not necessary that each that you will be able to understand each and every statement of research papers. Most probably, on an average, around 30-40% of content is understandable. Okay, so it's not mandatory that, or it is not expected that each and every line of a research papers should be or you will be in a position to understand it. It can be done if you have a multiple iterations. Okay, so if you want to understand more, you will have to read the same text again. Okay, more you read, more information you will get from the same paragraph. So if you read a paragraph 2 times, you will get some information. If you again read it for 4 more times, you will get some more extra information from the same set of paragraph or from the same set of statements. So more you read, more you will understand. And particularly for me, I think the reading, we can say the pace, or we can say speed, reading speed is around half an hour or 1 hour per page. Okay, or it may be more also. So that depends upon your grasping speed. So let me talk about the complete course. What should be the orientation, or what should be the flow of the course? So first of all, we'll talk about basics of graph theory, some prerequisites. Then we'll talk about the basics of big graph data. They are required because we will be dealing with the big, now we're building a graph database. So you need to have a fair bit of idea about the numerical values that we will be calculating from a graph database. Okay, so these are the first two things that will build up the base, and at the end you will be getting a numbers out of the whole graph. Okay, then we'll talk about representation learning for a graph, where we'll be talking about node and graph embedding. Then some applications, or not application, we will be working on the classification activities on a graph database. So those can be considered as a machine learning on a graph. So first thing is label propagation for the node classification, for the GNN framework, attention framework, and graph convolution network. Then we'll talk about a bit of link prediction, then RNN, algebraic graph neural network, then deep generative model, then an important theorem or important topic related to GNN is WL algorithm or Wishfall-Lehman algorithm, stability properties. Then we'll talk about a bit of applications of graph neural network in subgraph mining, recommendation system, knowledge graph embedding with reasoning, then community structures in network. And there are some more topics. If time permits, we'll be able to cover it. Okay, so this is the whole flow of the course. To make the thing simple, if I would like to say, as I've already mentioned, what is a graph neural network in an easy way? It is nothing. It is the deep learning on a graph. Okay, so deep learning means you need to know. So deep learning is the basic prerequisite for this graph. For deep learning, you need to know machine learning. Okay. And then you need to know, for machine learning, you need to know ACI. Okay. So each and everything can be considered as a chain. Okay. But somehow we'll be covering those topics again in our own way, because the traditional algorithm that you have learned in your machine learning, deep learning course will not be directly applicable for a graph neural network. The reason being is that here the graph structure is very huge, okay, with the millions of nodes and billions of edges. So the traditional, we can say, exponential, no, not polynomial time algorithm cannot be directly applicable. They'll have to change. We'll have to tune a bit. We'll have to change a bit so that they can be applicable. They can be applied for a big graphs. Okay, so this is the whole structure of the course. I would like to answer any query if you do have. So I have unmuted. We are hearing an echo when others are speaking. That is a technical problem. We are going to touch upon the graph transformers. Not exactly transformers, but if time permits, we can. Will the assignment be individual or group? So assignment will be group assignment, but your individual efforts are requested. Neo4j, yes. Will we be having any exposure towards Neo4j and all? So in the webinar, I will request Professor Vipin to covers those basic tools that we will be using for graph neural network. Okay, so he will be, but not complete tutorial will not be there. He will be explaining you something. Rest you will have to try at your own. Okay, but definitely we are here to resolve any query or to support you for any type of problems. So there won't be a full tutorial based on, we can say we won't be investing full 2 hours or 4 hours just for those tools. Okay, but we will give you a brief idea how to use them. How it is related to PGM course, which we studied in semester 2, PGM mean probabilistic graphical model. We can say the as you have already learned your PGM probabilistic graphical model, then basically the probabilistic graphical model is used to generate the graph probabilistically. Okay, so which we will be partially using in a deep generative model, but most or in an easy way, graph neural network is nothing. It is the class. We will be performing the classification activity on a graph. Okay, so if it is the classification activity, classification means we have some partial data. Okay, based on the existing data, we will try to predict the labels of an unlabeled portion, so that if that unlabeled portion is a node, then we'll call it as node classification. Okay, so node classification, where it can be used. So suppose, for example, in a huge bank database, if some new customers have joined, what type of card should be assigned to him, or what should be the class assigned to him, whether he should be given as a gold customer, what type of customer he should be considered, gold customer, platinum customer, or silver customer, or just we can say normal customer. Okay, so that we call it as node classification. If that activity is related to a new edge, okay, labels of a new edge or existence of a new edge. Okay, so if we are answering it whether there should be an edge between two node or not, that we can call it as recommendation system or friend suggestion. Okay, so that's again an application, and that's again a classification activity, whether there should be an edge or not, 0 or 1. Okay, if a new edge has been created, what should be the label of that edge? Okay, so the predicting a label of a newly added edge, that will comes under the category of recommendation system, or we can say not recommendation system, a link prediction. Okay, so first of all, the link prediction is of it can be two-step, not two-step, can be in a two ways. First of all, whether there should be an edge between two nodes or not, or if an edge has been created, then what should be the label of that edge. Okay, so this is the whole, we can say all the, and suppose the third one, if we want to assign a label to a subgraph. Okay, so that we call it as graph classification. So ultimately, in all the three ways, we are performing the classification activity on a graph using the neural network, so that our prediction or our model is far more better or more accurate. Okay, with lesser chance of error, and the model learns by himself. So this is the whole crux of the course. Whereas in PGM, probabilistic graphical model, you have learned the way of constructing a graph in a probabilistic way. Okay, which is one module in our course, which is deep generative model. So we'll be using some concept of PGM that you have learned into the deep generative model. Okay, but GNN is far more, not far more, is something extra than PGM. And that something extra is the classification activities. Okay, so I hope, Bhushan, I have answered your query. What are the what the benefit to learn neural network over graph instead of classical approach? Correct. So classical approach means whenever you are dealing with the Euclidean data. Okay, so suppose you have two values, the same like your data mining or IDS course. You have those values, and then you can subtract those two values, and you can minimize the error. You can say variation loss or whatever it be. Okay, the loss functions, but you were dealing with the numerical values. So numerical values you can subtract, you can add, and something else. Fine. So this is the classical approach. But when you are dealing with the graph data, you cannot add two nodes. Okay, although we have an option of adding two nodes by merging it, but it doesn't works every time. Okay, so two nodes cannot be added, two edges cannot be added, two nodes cannot be subtracted. So all the Euclidean activities, subtraction, plus, minus, multiplication, division, and all, cannot be applied on a graph data or a we can say graph network directly. Okay, we can do that, but with a different way of handling, by a different way. Okay, so that's why we will be learning. That is the difference between the neural network, or we can say GNN, over the classical approach. Okay, so here we'll be dealing with the graph database. Okay, now why graph? Because if I do have a normal values, I can perform in number of way. I have all the ways of deep learning, neural network, and all those things. But somehow, if we have a problem in which I can convert the node problem into a node points and their interconnections. So if I can convert a problem into a mathematical problem, and that mathematical problem into a point and their interconnection problem, okay, then I can use the graph approach to solve it. And although I cannot say that GNN is the only way of solving it, but GNN is one of the way of solving complex problems in a better way with a more accuracy. Okay, so I'm not saying that classical approach doesn't work. Always it works. That's why we are using the concepts of classical approach applying on a graph database. Okay, so almost the same, but the perspective or the application area is something different. Here we'll be dealing on the basis of the graph. We have converted the problem into a nodes and their interconnections. So I'm using the benefit of graph. I'm using the benefit of graph neural network. Sorry, graph algorithms. Okay, I'm using the benefit of the other neural network approach. Okay, I can convert I can convert the graph into a default neural networks. Okay, so where the graph and their interconnections works as a neural network. Will we learn how to build knowledge graph and RDF templates? Knowledge graph, I can say. RDF means relational database. So Arpan, I'll come back to you. Please explain what that RDF means for you. Will it give us enough background to learn, implement upon graph transformers research papers? Yes, I'll try to give you. Okay, but not graph transformations, because graph transformation is one of the application. If time permits, I can cover it. Okay, but in that case, if the number of the percentage of individuals asking for this graph transformation is more, then I can uh, tweak. I can make a slight adjustment into the content delivery, and we can cover the graph transformers. Please give us a real-time use cases of GNN. I haven't worked on anything related to graph database. Do I need to cover up additional prerequisite? Not necessary. The prerequisite is the machine learning. First of all, HCI, then machine learning, then deep learning, and then simple mathematics. That's all. But deep learning is a essential prerequisite. Fraud detection, PGM model uncertainty, transaction pattern, GNN learns in embedding for the accounts and prediction fraudulent. Together, a system that predict fraud and quantify coincidence, confidence. Yes, we can. Fraud detection, outlier detection is one of the area of application of GNN. And here we'll try to make our model intelligent so that model itself try to generate them. Would you be covering the graph convolution network? Yes. Yes, Arun. Manoranjan Das, can I use graph theory to know flow, which is causing looping? Graph theory will be used, but only for the loop. We'll be using it for a lot more activities. Will this be applicable when we have a multi-model data like memes, wherever we see text and images? Not exactly. We'll not be dealing with these images, but somehow, text again we can. And multi-model data, we'll be dealing with the knowledge graph where each nodes have multiple attributes, each edge will have multiple attributes. So in some sense, yes. Real scenarios, this GNN is already applied in anything we already seen implemented. You will be doing some assignment on which you'll be working on a real data that is being provided by the organization for free. We will be using them and we will be applying them for our own activities. Okay, so there will not be anything dummy. We'll be working on a real data which have been provided to us by the organizations. Does it involve heavy math? Not that much, but conceptually. But you'll have to. Math is not scary. If you have understood the concept, then math is easy. But definitely we'll be having some mathematics, but I will try to make it in a digestive form so that you can easily digest it. Okay, so I'll try to make it pre-digested. Like Google Map uses GNN, yes, it is for routing purpose. Okay, and for self-learning. Wherever you want a model to learn by himself based on the graph structure, there GNN is applicable. Okay, so model will learn from himself and from the past data. So that's again a training, and then all those things of deep learning and all where are there. The source description template in knowledge graph tells then what the graph look like, and GNN is more learning from it. Um, not to that deep, but we'll be dealing with the knowledge graphs, but not in a particular area of domain, or we can say in which you want. But if you want, if you're working on this area, then definitely out of the bound we can connect together and we can try to solve it, because it will be hard for me because to explain you the particular application or to explain the application of GNN on a particular domain or a particular small area, because there I think we have around 200 student and from the diverse field. So it will not be justified that, or it will not be feasible for you to give them a real-time application for their own working. Okay, so but definitely for one-to-one, I'm there available. Okay, you can reach out to me through mail and all. We can work together. Apart from the course, because hardly a course matters. Course will be of around 400 for 4 months, but if you want, we can be connected even the post course also, on even during the during the course as well for the other activities. Ultimately, ultimately we'll be explaining the graph in the form of the classification activities only. No, I will be giving you the references. Those references will be listed bottom of the slide. Okay. And the papers which I'll be explaining or which I'll be using for while preparing the slides are freely available. Most of them are freely available. You can directly download it using Google Scholar. Okay. So you just type it, and I will also be opening few research papers for you, something like this. So you will be some of those papers are available directly. Most of the papers are available directly. Some may not be directly through this link. Okay, but most of them are available on the link which is mentioned to the right hand side. Okay, so this is, although some of them are directly available, although this is not related to you, this is something related to mining activity. Okay, this requires password, whereas the same paper is available using the link which is mentioned in the right. So most of the time they are available. I will also share the link, the title itself. Okay, any more queries? I think it's time to go. It's time to go ahead. Frankly speaking, I will not make this course scary. Okay, I'll try to make this course as easy as possible. Okay, but I request your support also for the continuous reading. If you are with me, I can increase my pace. I can cover some more topics. Okay, but the covering of topics will not be on the cost of your learning. So if you're not able to grasp certain material, then just for the sake of completeness, I'm not going to cover it. We can skip it. Hardly 2 sections, so that can be managed. Okay, good. Should we continue? Chalo. So first of all, let us beat around the bush and let us start with the graph and then graph theory and then big graph, and then we'll move towards graph neural network. So first, for a few days, we'll be talking about graphs, graph theory, big graph, and so on. So how does graph theory originate? Okay, if I go as per the book, um, there was a person with the name Euler. Okay, you may found this name at many places. Euler. Okay, so the pronunciation of this name is Euler. His full name is Leonard Euler. He lived from, he was born in 1707 and till 1783, but during that tenure of around 76 years, he had made he had worked a lot in the area of mathematics and especially graph theory. Okay, so I think in your Euler diagram, Euler graph, and many more, some Euler theorems are also there. So he was a good mathematician, works in the area of graphs and algebra. So in some time, not somewhere between 7 to 1783, he was asked to solve a particular problem, and the name of that problem was Koenigsberg bridge problem. Okay, so Koenigsberg bridge problem. What does a Koenigsberg means? There was a town, okay, and that was surrounded by a we can say river. So there was some part of the land which was covered by the river streams. So there were there were many land areas, and all those land areas were connected by a bridge. So that city was connected, the parts of the city was connected by 7 different bridge. Okay. So A land, land was marked as labeled as A, then B, then C, then D. And they were connected by 7 bridges. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 bridges. And the problem was you can start a walk, means you can start from any part of the graph, in any part of the city, somewhere in Koenigsberg, walk across each of the 7 bridges exactly once. Okay, so you just walk through those towns, those bridges exactly once, but you'll have to come back to the starting point. Okay, so that means this walk, we have come across 6 bridges, but I cannot continue again because all the bridges which are approachable from this point are already traversed. This is already left, and this is the starting point. So that means this is not a correct solution. Let us try for something else. Okay, so suppose, for example, he start from this one. So 1, 2, 3, 4, 5, 6. Again, he started with this point and he terminated at this point. 1 bridge is again left. Okay, so this problem was you'll have to cover, or you'll have to traverse each bridge exactly once, and you'll have to come back to the starting point. So this give rise to a new area of mathematics. We call it as graph theory. Okay, so this was the first known, or you can say published problem that give rise to a new area of mathematics. We call it as graph theory. So why we study graphs? So graph provides a universal representation of a data. Data in any domain can be structured as a graph, either in the form of social network or in the form of transportation network or in the form of protein-protein interaction and so on. Now, how come a social network be converted in the form of a graph? So how can there are multiple ways by which a social network graph can be constructed. First, on the user basis. Okay, so for example, you can take Facebook. So if I'm the user, okay, so if that network is based on the friends, so I may have 500 friends in my account. So if I connect them by an edge, that will be my friend network. So suppose Ankur is a friend of Pachori. Pachori may have again 400 friends. Some of them may be outside, some of them may be repeated. Okay, so that's again, and same as the case with this one, B with C, D, E, and so on. So there each user will have their own friends and a network can be constructed. So that is one type of network, which is the user connectivity. Who is connected to whom? Okay, and that is static. If a new member, still Facebook suggests me, even though I have 500 friends, even friends, Facebook suggest me a new friend suggestion, suggest me a new friends. Okay, I can send them invite. If he accept it, that may be my 501 friend. Okay, and so on. So that users grow, so that network grow, as well as it can shrink also. I can unfriend 10 of my friend. I can do that. So that means my friend network will shrink from 500 to 490. Okay, so accepting a request or unfriending someone, that may be one network. Even for the Facebook, who follows whom? Okay, so users and their followers, that can be another network. Okay, I am a user, I'm following someone, and someone is being followed by me. Someone is following me, I'm following someone. Okay, so that's again a different network. Same like LinkedIn. I'm following someone, someone is following my update. Same as the case with the ResearchGate. I'm following the research area of someone, and someone else is following the research areas or research papers of me. Okay, so that is back and forth. I may be following a person who is following me. So they can be loop also. Okay, now same for the Facebook. They can be, I do have 500 friends, but not necessary that I am sharing the details or the videos or something, videos or to everyone. I'm sharing the material, I'm sharing the media to selected person. Okay, pinching them, poking them. So I'm not poking every of my 400 friends, a few of them. I'm testing a message. I'm wishing someone. So I'm not wishing all my 500 friends. I'm wishing around 20 to 30 friends of mine only for the new year, for the birthday wish, and so on. So there can be multiple type of network, multiple structure of network on a same social network. Okay. So in every structure, the properties of this graph will be different. Properties of this graph will be different. Properties of this graph can be will be different. Whatever analysis I have done on this type of graph will not be applicable for this graph. Okay. This graph may have a different way of interaction. For this, I'll have to, or this may, for this, I'll have to execute the same algorithm again. Although they are from the Facebook only, Facebook user structure, but the information which I have gained by executing the algorithm on this graph will not be the same or will be different from executing the algorithm on this graph structure. It will be different. Okay, even the graph will be different. The another example, WhatsApp. So the messages, they can be multiple type of network. When a WhatsApp, I'm messaging someone. So if I do have 1,000 contacts in my phone book, all of them are available for me, okay, for the interaction, but I didn't interact with all of them. Okay, I may be interacting with very few of them regularly on the messages or through phone calls, voice call, and video call. So there are three different type of network again in a WhatsApp: messaging, audio calls, video calls. Okay, same is the case. I may be receiving a multiple broadcast messages, which I'm not forwarding it to other. I may be forwarding to some of the other persons also. Okay, so that network, broadcasting network may be different. Okay, so if I'm owning a we can say business, and I want to advertise my business, I will be publishing, or I'll be sharing those videos to multiple users, multiple of my friend, multiple persons from the phone into my network. So that behavior will be different. Okay, same is the case now. I think we have a status sharing and DP sharing and something. So that can be a different network. So even a same social media can have a different type of network with certain properties. Okay, so we'll be dealing with the different type of other. So social media, transportation network, protein-protein interaction. So protein-protein interaction means, and now this protein-protein interaction is of two types: bioinformatics. Okay, so like interaction of the genes. Okay, which gene is connected to which, and what is the sequence, and which sequence is responsible for which type of genetic property. Okay, so just based on the structure, based on the genome sequence, we are trying to predict certain activities. Okay, I think you all are working professionals, and you all are grown-ups, students, grown-up persons. You some or the other time of your life, you might have performed a test for Down syndrome in a pregnant woman's. Okay, in the early ages, in the not ages, early time of the pregnancy, a test has been conducted for the Down syndrome. Okay, so Down syndrome is some mental disorder, disease, which the test predict whether the child is suffering from a Down syndrome or not. That's not 100% test, but still it it increases the chance of being detected. Okay, even though if it is negative, it doesn't guarantee that the child will not be suffering from the Down syndrome. It may be, but the chances will be less. Okay, so false positive, false negative, they have, but it is again based on some gene interaction. So based on certain gene interaction, we are trying to predict whether a disease can be there or not. So that's again a area of graph classification. Okay. Many real-world application can be formulated as computational task in a graph. So for inferring node attributes, detecting the anomalous node classification, predicting relationship between the nodes, means the edges, link prediction, and so on. So ultimately, we will be doing the classification activity in some of the other forms throughout this course. Okay, ready to answer the questions. Now, I think this problem is unsolvable with no solution exist. Uh, we see maps about the COVID areas in the past. Does it use this graph network? Yes, it is. The points and the interconnection. Somehow, if we can convert everything in the form of a points and their interconnection, we can use the graph neural network. Okay, let's talk about the solution. The beauty of mathematics is, if I want to say a problem is solvable, what all I need to have? I need to come up with a solution. Okay, either in a constant time, or in a linear time, or in an exponential time. Okay, but the only thing is, I'll have to come up at least with one solution. Then I can say that this problem is solvable. Fine, somehow I can get it. Even though my problem is exponential, solution, matlab the complexity is exponential, still I can get if still I can say the problem is solvable. But if I'll have to prove that the problem is unsolvable, then I can only say, I can say that the problem is unsolvable only if I have tried each and every method. Okay, if I have tried each and every possible way of solving it, and none of them had resulted in a solution. So if for all those cases, then I can say the problem is unsolvable. And I think the Euler problem is, let me check whether this Cohenusberg bridge problem is solvable or not. Solution, it is there. Let me check. I think it is. Cohenusberg problem has no solution. Okay, so but in that case, to say it is unsolvable, that need to be proven. In 1736, he come up with the problem, and the solution is, it is unsolvable. Okay, fine. Should I move ahead? So what type of graph data that we will be handling with? Okay, so I think I have explained a lot about the social network, users and their interactions. Okay, even one social media can have a different type of network. Okay, even for us also, even the telecommunication as well. Okay, so the numbers in my phone book can be considered as nodes, or my neighborhood. Okay, then to whom I'm sending the SMS is one type of network. To whom I'm calling can be the another network. Or audio calling, to whom I'm making a video call, can be the another network, and all the three networks may be different from each other, or will be the different from each other.
Let's go.
Okay. Yeah. Okay, I'll come up with it. Then chemical compound. Okay, protein structures. So this I have explained. This I have explained. Protein structures means one is the genetic structures. Okay, even in the terms of in the activities of hormones. Okay, so which hormone is working for which type? How the hormone releasing can be controlled in something. Okay, so all the metabolic activities, or we can say drug identification, or we can say performance of a drug on a body, how the protein react with some other protein, the digestion system, and many more things. Okay, so that we call it as protein-protein interaction. Okay, and the major part of protein-protein interaction is the bioinformatics, genetic information, genetic combinations. Okay, so this we have discussed. Program flow, I'll explain those two. Program flow means the flow of the program can also be converted into the form of a graph. Okay, which module is being called. Okay, so if a module is being called, that can be converted into an edge. When he returns back, then a return edge. And somehow that whole graph or that flow can be converted into form of a graph. Okay, so either in the form of a data flow diagram or in the form of control flow diagram. So DFD or a CFD. Okay, how data is flowed, or how control is flowed, or how a program is being called. Not program, how the functions calling. Okay, that can also be converted into the form of a graph, and using that graph we can try to predict the errors, possible bug in a graph. Okay, so that's again is an area of graph neural network. So just by you just give them a code, give him a code, the program will convert the code into the form of a graph, and then based on the graph, he is trying to predict the possible area of bug. Okay, so your program, so software testing, automated software testing by the program itself. So the testing done by the program itself, tool, automated testing tools is an area of GNN. Fourth, when I'm talking about chemical data, okay, so chemical means those atoms, molecules, and their bonding together. Okay, so like a benzene ring, alternate, double, single bond, double bond, and so on. Okay, so chemical combined, sorry, carbon combined with hydrogen, combined with hydroxyl group, COOH, and something. Okay, H2O, whatever it be. So that's again is one form of graph data in which atoms or molecules can be considered as their nodes, and their connections, okay, their bonds, different types of bond can be converted, can be represented in the form of an edge. So a chemical compound can be converted in the form of a graph. So here we have 1, 2, 3, 4 different type of node with different type of edges and their connectivity. Okay, so that can also be an example for heterogeneous graph. Okay, so nodes can have multiple attributes. They can have multiple type of nodes as well, different type of edges, or each edge may have a different attributes, different properties. That's an example. Now, why we are trying to convert the chemical data into a graph data? The reason being is there is a property in chemistry, we call it as SAR. structure activity relationship. Okay, so what does this mean? This says that because researchers have already proven or researchers have observed that a particular structure, the structure of a chemical exhibits certain property. So it can be used in either way. If you can extract out the structure of a chemical, if you have extracted out the structure of a chemical, then you can predict it, the properties that this structure might exhibit or will exhibit. Okay, so based on the structure, you are predicting its probability. Okay, so where this drug can be useful. I have extracted out a drug, I have made a new chemical. Now I want to utilize where what this chemical for what this salt can be used for which type of disease. Okay, so that's one way. So if I have the structure, I can predict its probability. The other way is I have a disease to cure. So I have the disease. Now, what is the behavior of that virus or something? Based on that, I'm trying to predict the structure of the chemical, that which type of chemical can be used to cure this type of disease. So based on the structure, I can predict the probability. I can predict the, based on the structure, I can predict the property. If I have the property, I can predict the structure. What drug can be used to cure this disease? Okay, so it can be used in both the ways. And in both the ways, in either way, this is a prediction probability. Okay, so I think the second part we have seen during COVID. So first of all, if you can relate the things, first of all, we were trying to identify which virus it is. Then we were trying to extract out the virus from the human body. Then its genome sequence or whatever it be. Okay, and then based on that, we were trying to predict we were trying to identify the vaccine. Okay, which vaccine can be used to cure this? Okay, so that's again a prediction probability, means neural network. So this is the fourth type of data on which we will be working on. Now, fifth is co-expression network. Just give me a minute. Okay. So now co-expression network. Again, have you all gone through a research papers? I'll show you some. Then I'll answer your question. Okay. If you can read this paper, I think my screen is visible. This is the title of the paper. Okay, whatever the title is. These are the authors of the paper. So he may be the first author. He is the first author. He is the second author. He is the third author. This is their affiliations, where they are working. Okay. Then we have some index term, keywords we say. Okay, means these are the, just by looking at the keywords, I can identify that what type of paper is it and for what it is working. Okay, then if you are making any sentence, So the epidemiology could be used to result to recognize the community and the connection between the people in order to prevent the spread of disease. So if I make a statement, I'm giving a justification, I'm giving a reference that this is the researcher who had made this sentence. I'm just quoting this sentence, but this sentence was actually made by the researcher which is at the name, which is at the count one. Now look at the count one. What is it? Every research papers have one thing which you call it as references. So count one means, I think, is it visible? So count one is the research paper, community structures in social network application for epidemiological modeling. Somewhere PLOS 1, volume 6, number 7, page number this in the year 2021, and these are the authors. Okay, so the paper contains the title, the author, and the references. Now, if I wish to construct a graph out of it, now just have a look. When I copy and paste this paper on a Google Scholar, what will I get? I will get I will get some information. Okay, so this is the paper which I was looking for. Some text which I'm not bothered about as of now. It is cited by 76%. That means this is like following. So there are 76 researchers who had followed this paper. Okay? So that means if I convert this, if this is my paper A, it is being followed by 76 research papers, which is mentioned over here. You can just have a look. This paper was published in 2014. Okay, so that means all the other research papers were ahead of 2014. And these all are the papers who had followed, who had referred this paper, who had cited this paper. Okay, some count 2022, some 2023, some 2024, more 2025, almost some. Okay, so that means he was followed by 76 different papers, whereas he himself (12 research papers). So he referred 12 research papers. Okay, even this the paper which he had referred is this. He himself, that paper community structure means this one. Suppose he referred to paper number 1. Okay, so he himself was being referred by 55, means 54 others in addition to this one. So this paper, paper number 1, was being referred by 55 persons, including this. So 54 others. And he himself might be following some paper. Okay. So this is the paper, his paper. It is still processing. So that paper itself has a title, has those writers, their affiliations, their keywords, and so on. Okay, and he himself refers some papers. How many? He himself refers 39 different papers. So he is following 39. Okay, so if I expand this to all the other papers, that will again give me a bunch of, we can say the whole network. A cited by 76, he cites 12 others. The paper number 1 was cited by 54 others, 55 others, and he himself cite 39, and so on. Okay, so that this type of network, if we can expand it to all, okay, perform the web scraping, that's nothing, that's a web scraping. Okay, so if I perform the scraping for those research paper itself, that will give me the co-expression network. Now, from that paper, those bunch of papers, if you see, all of them may not be of the domain at which he is working at. He is working on the community structures for using some one algorithm detecting the community structure. Okay, but all the papers that he had referred might not be talking about the structuring, community structures. They might be of different domain, but he might have quoted one thing, quoted some other thing which he had referred into his paper. So that means it is not necessary that all the papers in this domain, all the papers extracted out, are of same domain. They may be different domain. So from the whole network, if I club the papers of a same working domain, they will form one community. So these are the papers working for clustering, edge classification. This may be the node classification. These may be the graph classification. This may be the link prediction. This may be for the recommendation system. This may be for subgraph mining. This may be for nearest network, nearest neighborhood, or many other things. Okay. So again, predicting a label of a particular paper. Now that will be easy. If I have started my research on this area, I can focus only on those bunch of papers which lying in the same domain. Now, domain can be predicted based on the keywords that is mentioned into the papers. Okay, either the keyword, or if I want to make my algorithm more intelligent, I can perform a text analysis, not text analysis, semantic analysis, or something, some sort of text mining on the abstract as well as on the conclusion, because these are the two sections which specifically talks about the content of the paper. The introduction may be talking about many other things. Once if you go through any paper, the important part of any research paper are the abstract and the conclusion, because they are the only things which talks about the content of the paper, the working, the methodology, the scope, or the identifying, or we can say whatever he had done. Introduction doesn't talks about specifically. Introduction talks about many things, beating around the bush, then some other things. Okay, so if I want to make my algorithm more intelligent, I can perform the text analysis based on the conclusion, based on the abstract, and then I can predict the label of that paper. That's again one area. Okay, so that's again the type of network that we will be working on. Okay, now one thing more. Specifically, if I create a, I started with one paper, the Greven Newman, this paper, okay, and I performed the web scraping based on those 12. I started with based on those 12, and then goes to those papers individually. I may have one type of network. Okay, I may have a full network, but that is specific to neural network, community detection, structure, we can say clustering, graph clustering, node clustering, and so on. My second area of working is the software test data generation. Okay, now the papers which I have researched or which I have written on a software test data generation will be totally disjoint from this graph structure. Okay, so in that case, although they both are complex structures with billions and millions of nodes, but maybe possible that both the graphs are disjoint. Both the graphs are different from each other. So it's not the case that it is the this is the whole world of research. No, this is not the whole world of research. This is the graph based on a particular domain, based on the particular area of expertise. So this may be for the neural network. This may be for classification activity. I may have a separate graph for my different research which I have done during my PhD. Software test data generation, that may be different. I may have some mingling communities in the third area of domain, which I call in which I have used nature inspired algorithm. Okay, I think few of them you might have learned. Genetic algorithm, ant colony optimization, particle swarm optimization, honeybee algorithm. You might have learned hill climbing and many more. Okay, so you might have gone through those name of those areas. Okay, so they may be a different set, and there may be a we can say subset. We can say that we can have a overlap. Someone might have used genetic algorithm for node classification, and I have used genetic algorithm for test data generation. Okay, so this is my area A, this is my area B for research, this is my area C of research. They may be disjoint, they may be interconnection. Okay, so that is something different, but somehow I just don't want to confuse you, but this is how the network can be constructed from anything. Okay, now 1:32, 3:40. Oh, hardly 40 minutes are left. Sorry, I was beating around the bush, but I would like to give you the look and feel of this course. Okay, let me answer the questions. Sir, will we see the map? Okay, so we're learning how GNN can be used for functional approximation for optimal state action values policies for different RL algorithm. Not specific, but if you want to work, we both can work together. Because as I've already mentioned, it will be difficult for me to convert or to explain the GNN based on your own expertise. But because I'll have to satisfy 200 people. Okay, but if you want, then we can work together parallelly in your own domain, and I can work for 10 or 20 different persons. Okay, I don't have any problem. So if you want to be specific in your area, we can work together. But unfortunately, I'm afraid that I can include specifically your topic into my lecture delivery. We can, if there's a coincide, we can cover it during our course content also. But not specifically for your requirement. Okay, but if you want, we can work together. Can we have graph database replace normal relational database in transaction data scenarios? Yes, we can. As they deal with the relation between data, we are already used in GraphQL. Okay, graph query language. So GraphQL is a tool that is used for the mining purpose. Now we are one step ahead of graph mining. We are moving in the area of classification. So graph classification, node classification, and edge classification. But yes, can you please repeat what about automated software testing? Okay, you can call me directly. I can explain you about my PhD topic. So automated software testing means generation of those test cases such that we can identify the bug. And I have used a nature-inspired algorithm to generate those test cases. So Venugopal, if you want to understand more, you can directly call me. I've worked a lot in this area. Can we use GNN to address network topology problem in environment where topology changes dynamically at runtime? I need to think. Definitely we can, but how? I need to think. So can we use GNN to address network topology problem in environment where topology changes dynamically at random? So here topology, you're talking about the content of the network, Bhupendra? Topology means the routers and all in between, routers, servers and all, structure of the network. Okay, fine. The change in network, so that's again, we have a full chapter on dynamic graph as well. So dynamic graph, but effectively, to be very frank, although we say that our algorithm is good enough that it works on dynamic graph, okay, we can, but the ultimate truth is that whatever algorithm that we have designed so far only works for static graph. Okay, but you can make, or we can make a slight change into those set of algorithm so that it also handles the dynamic graph. How? The same algorithm we will be executing frequently with the changed graph and then compare the result. Okay, so this is how we deal with the dynamic graph, but ultimately we are executing the algorithm on a static graph, but frequently, and then identifying the changes. So this is how we deal with the dynamic graph. So it doesn't, so suppose for example, the moment one server is down, automatically, if one server is down, then automatically the routing algorithm again executes it to find out the alternate way. Okay, but alternate way means doing it on a static graph without that part of a graph. Okay, so base ultimately करेंगे हम static graph पर ही, लेकिन we'll be doing it very frequently to give a feeling that we are dealing with a dynamic graph. Yeah, Bhupendra, I think I have answered. Okay, now a small, there are two requests. First is, because of my handwriting is not that good. You might have understood that whatever I have written, okay, so it's not that readable. So if you want, you can, I request you to note down those words in your own handwriting also, because you won't be able to read it. I can read it. This I have written function, this functional calling. Okay, so although this functional is not there, but I know that I have written functional. Okay, so NAL is missing, but functional calling. So I can understand, but I cannot guarantee that you will be able to understand it every time. So I request you to keep noting down in your own paper also. Okay, so you can prepare a notes during the sessions, and you can write down those points. Okay. And the second thing is, I usually do not take a break for those 2 hours. So if you want, you can ping me that you want a break. I have a habit of continuously speaking for 2 hours. As I think you already have observed, right from 1:40 to 3:10. How much? 1.5 hours I'm continuously speaking. So that's my job. I'll have to speak, but I know that grasping, because it's already post lunch. Okay, so you may be feeling a bit sleepy. So if you want to wake up, you want a break, then please ping me. We can have a 5 or 10 minutes break. It's not it's not a rule that I won't take a break. I can, but usually I forgot to take a break. That is the basic. Matlab, it's not the case that I doesn't take a break. While speaking continuously, I forgot to take a break. Okay. So if you want a break, you can ping me for 5 minutes break. I can take it, or I will allow you to take it. I'm trying to understand the product knowledge base from the log files. Will it be possible? Is it for automated test? Understand the product knowledge base from the log files. Now it depends upon the data. Okay, definitely. In any way, we can convert it in anything into a graph form, but I'll have to understand the data first. So Arpan, if you want, I can. You can directly. We both can sit together and we can discuss. Just a general question, if I can ask, what is the pass percentage of this subject so far? Usually, nobody have been failed except one or two who skip those midsem and compre. Rest all are pass. So please do not focus only on the passing criteria or what should be the content of the question paper, what type of question paper it will be. Please do not, please be one step ahead from those materialistic thing. Okay, I'm not a Khados teacher. I doesn't want anybody to fail, but I'll try to transfer the knowledge as maximum as possible. Okay. But we started with the count of 90, I think 96, and we are left with 74. Do we have any parallel sessions so far? I think there's only one section, na?
Yes, sir.
Yes,
Just
sir.
one.
Just one.
Just one section. Okay. So that means people have dropped.
Post lunch.
Post lunch.
Impact.
Impact.
Post lunch. Um, okay. So in that case, you have my mail ID. It is there. Okay. And this is my number. You can WhatsApp me, or you can call me if that is too urgent. We can work together. Okay, chalo, let's move ahead. Hardly half an hour. Okay. Yeah, Arpan, you can reach out to me. I'm reachable too. Okay, so basics of graph theory. I think graph terminologies means node. I think you all are clear what is the node and the edges. Huh? Dependent nodes are the nodes which have single degree. Degree 1. Okay, so all those nodes which have the degree 1 are called as pendant node. The reason why they are important, because if I'm working in, if I'm going through a network, okay, then I have an option of coming from one edge and going out from the another edge. Okay, so in this way, the multiple edges or nodes with multiple degree or greater than 1 degree may be useful. The nodes with degree 1 will be called as pendant vertex, or the another name, hanging node. Why they are important to study is that they have only one way to go in and one way to go out. If I'm allowed to traverse the same edge again. Okay. Or if I have a restriction that I cannot traverse the same edge again, then if from any node, if I move to this node, I'm dead. So this can be considered as a dead end. If travel restriction is there. If travel restriction of one way. Okay. So if that's one way, if it is a directed graph, okay. So if this is a directed graph, then I doesn't have any way to move out. If it is with the out degree, in degree greater than 1 and out degree 0, okay, there may be possibility that in degree 0 or out degree 1. So in that case, this node can only transfer, inject something into the network, but cannot get anything from the network. This type of node can get the can get anything from the network, but cannot give anything to the network. Okay, so that's why those nodes with degree 1 are probabiltic, or we can say somehow we can say that those nodes creates a problem for us. Or hanging nodes or pendant nodes, node with degree 1. So either in degree 1 or out degree 1 or total degree 1, whatever it be. Okay. Simple graph, degree and degree distribution. So degree of the graph, degree of the node means the total number of edges incident on that node will be the degree of that node. The degree of a graph will be the highest degree of the node will be the degree of a graph. Now, simple graph means with no self loop, no parallel edges. Multiple graphs means with parallel edges. Now, there's one word which is called as degree distribution. What does that mean? And why it is being used? So degree distribution means, suppose, for example, if this is the graph, how many nodes I have with, we can say, not how many nodes. What is the degree of each node? This degree has two, this node has a degree 2, this node has a degree 2, this node has a degree 4, this node has a degree 3, this node has a degree 2, this node has a degree 2, and this node has a degree 1. So how many nodes are there? 7. Okay. What is the distribution of degree? Degree is either 1 or 2 or 3 or 4. So this is the degrees of a node. Now, how many nodes are there with degree 1? P1 equals to 1 by total number of nodes, 7. So P1 degree of nodes with, what is the distribution? What is the percentage of the node, or what is the dominance of the nodes with degree 1? 1 out of 7. For P2 means how many nodes are there with degree 2? 1, 2, 3, 4. So P2 is 4 by 7. So there are 4 nodes with degree 2 out of 7. So the dominance, so percentage of contribution of nodes with degree 2 in the whole graph is 4 by 7. Contribution of nodes with degree 1 is 1 by 7. Contribution of nodes with degree 3 is 1, so 1 by 7. So P3 is 1 by 7. The contribution of nodes with degree 4 is 1 out of 7. So P4 is 1 by 7. So when I sum all PIs, sum of all PIs is equals to 1. Means total contribution for all the degrees is 1. So 1 plus 4, 5, plus 1, 6, plus 1, 7. So 7 by 7 means 1. So sum of all the contributions equals to 1. So that means this is normalized. Okay. So what is the percentage? 1 by 7, 4 by 7, 1 by 7, 1 by 7. Now, what is the use of converting this graph into this form? Now, I think if you have gone through a course with the name ISM, had you was it your course in the first year?
Yes, sir.
Introduction to statistical method. Now, so now if I have to apply any of the statistical tool based on the graph data, okay, so that is one way. And degree of, so this is based on the structural property. So this distribution of the graph is based on the structural distribution. Okay, so somehow if I have to convert the graph in the form of a distribution on the basis of the structural information, then I can use the concept of degree distributions, and I have converted the whole graph into the form of a distribution. Now I can use any method for statistical, any of the statistical method to perform my analysis, to perform my hypothesis testing. Okay, even to perform any sort of prediction as well. Not distributed machine learning. Distributed machine learning is something different. It is far more than this. This way, I'm just converting a graph into the form of a distribution. Distributed machine learning is something different. Okay. I think I have not confused you. Please do not take it in the area of distributed machine learning. The main intention is, or we can remove it also. The main ways I have converted the graph in the form of a distribution using the structural information of a graph. If it is, I can use in any of the statistical tool to apply or to perform any sort of analysis. Now, weighted and unweighted graph means, suppose same. Unweighted graph means edges doesn't have any labels. Okay, edges doesn't have any count or any value any number associated with them. So those graphs are called as unweighted. Now, if I have the weights associated with the graph, so that graph is called as weighted graph. Okay, so that means what is the impact of weighted graph in it? So that means if somehow you have to assign importance to those edges while performing your analysis, while doing all your classification activity, if you have to assign the importance to certain edges, then it's better to use the weighted graph. Okay, the example, I think you have heard about the attention network. Had you heard about the attention network?
Yes, sir.
So attention network is nothing. It is the weighted form of the simple concept. Whatever the concept is, in the weight, if I assign the importance, if I assign the weightage associated with certain calculations, so that is called as attention network. So here in this case, we will be dealing with the graph attention network. So graph attention network is nothing. We are adding the weights along with the edges. So yes or no means existence of an edge, yes or not. If yes, then what is the importance assigned to that edge? Okay, so that is weighted graph. Then and the same can and this is where it can be applied. Okay, directed and undirected graph means edges with the direction. Storage of the graph either in the form of a matrix or in the form of a list. Different types of graph: tree, forest, spanning tree. Traversal, depth first traversal and breadth first traversal. Breadth first search. Okay, so either in the form of a depth first. So here in the depth first, we are diving deep into the graph. Okay, So we are talking about the connectivity here. So whenever I'm bothered about the connectivity, diving towards the deep connectivity from the source to destination, then the better way is I'll have to use the DFS traversal. But if I'm bothered about the neighborhood only, for the I'm giving more importance to the neighborhood, neighboring search. Okay, k nearest neighbor or something, neighborhood search. If I'll have to implement the neighborhood search, then the best way of traversal into the graph will be the BFS, because every time I'm bothered about my neighborhood. Okay, then one step ahead, then his neighborhood, neighbor of a neighbor, then neighbor of a neighbor of a neighbor. So in that case, the BFS traversal will be beneficial. Okay, path connected and disconnected, that's I think I have already explained you. Handshaking theorem or degree sum theorem means total degree. I think simple graph theory algorithm is there. The total sum of degrees will be equal to twice the number of edges and all. Okay, so twice the number of edges, half of the number of edges. Total degree of a graph will be twice the number of edges. Degree equals to 2a. So that is degree sum theorem. Okay, degree sequence. How much time do I have? A distribution will tell you the concentration of nodes and how, okay, what could represent weights of an edges. So weight of those edges can be either the importance or the path length or the manufacture or the cost of traversal, cost of passing the information or something. Okay, that depends. Any number associated with that edge. So Manoranjan, I think that's clear.
Yes, sir. Yes.
Manoranjan, I think you've done something in non-specific also, kya? Or that may be someone else, because I've been the mentor of someone with the same name in non-specific for dissertation. I'm not yet doing the degree again.
No, no, sir.
Okay, so that might be someone else. Okay, there's a theorem, Havel-Hakimi theorem for sequence. I do have a time. I do have. Okay. Now, what does this theorem tell? So this is a theorem you are given with the degree sequence. Okay, sequence of the degree of each nodes of a graph, and using some way we can find out whether the sequence is for a valid graph or not. Okay, so this is how somehow we can find out whether, if we are given with the sequence of the degree, whether are we able to construct a graph out of that sequence or not, or whether that sequence is correct or not. So it provides a method to determine if a given degree sequence can represent the degree of vertices in a simple graph or not. Or in other way, are we able to draw a graph based on the given sequence? So how do we do that? These are the simple steps. You start with the non-increasing sequence of degree. Okay, there's a difference between non-increasing and decreasing. Somehow you might have observed non-increasing or non-decreasing. Okay, so non-increasing means decreasing with equals to. Okay, so non-increasing sequence of degree. So that means you have to sort them in a decreasing order. Then remove the largest node and decrement the next largest degree by 1. Okay, so that means if this is 3, So suppose if I have extracted out 3, I have drawn. So if this is node A, B, C, D, E. Okay. So that means if I have removed this, that means I'm working on a node with degree 3. Okay. So this node will have a degree 3, means it is connected to 3 different nodes. Then this 3 means I'll have to connect, sorry, I'll have to reduce the degree by 1. So decrement the next DI nodes. It should be 1. It should be DI. Okay, DI by degree by 1. Repeat this process with the updated sequence until all degree becomes 0. Okay, so that means all the degrees become 0. So now 1. Now you are at this node. Now you remove this. Okay, so that means you add 1 and you decrement 1 from number. So it is 1. So that means you decrement 1 node by 1. Okay, so that means this 0, 0. So that means 0, 0, you'll have to stop, and this is left. So that means by this way, this sequence is not a valid sequence. You cannot construct a node, sorry, you cannot construct a graph using if you're given with this sequence. So you'll have to repeat this process with the updated sequence until all degree becomes 0. So if all the degree becomes 0, that means yes, you can proceed further, but all of them become 0. So if all of them become 0, that means that's a valid one. But if algorithm fails to proceed, that means not a correct sequence. So this is how, by this way, you can check the correctness of the given sequence of graph, given degree sequence of the graph. Now, why this is important? The reason why this is important, because and why we will have to come up with a simple method. The reason being is we will be dealing with the huge graphs, okay, with n number of edges, with millions of edges and millions of nodes and billions of edges. Okay, why I'm specifically keeping the number of nodes smaller than the number of edges, because in a bigger graph, the number of edges are far more than the number of nodes. So that's why I'm intentionally saying millions of edges and billions of, sorry, millions of nodes and billions of edges. Okay. Now, so if I have to deal with the millions of edges, millions of nodes, then I need to come up with a simple method to check the correctness of that graph again. Because at the end, I executed the graph, I executed the algorithm, and at the end, I came to know, oh, that is not a correct graph. Then all my effort will go into vain. So that's why I should have a simple way of checking whether the graph given to me, the degree sequence given to me, is correct or not. If it is not correct, then there is no need to execute the algorithm on that given sequence of nodes. Okay, so that's why this title is being included. Complement of a graph. Okay, so complement means just reverse. So if if there's a graph, if there is an edge in the original graph, you remove it. Okay, that in the complement graph, that edge will not be there. And if there is no edge between two nodes in the current graph, then its complement will have a edge into that graph. Okay, so that means graph and its complement will merge together to create a complete graph. Okay, so a graph is said to be complete if every node is connected to every other node of a graph. Okay, so that we call it as complete graph. Now, why that complete graph is important? Because the connectivity is, we can say that graph is dense. Okay, because every node is connected to every other node, so density is at the peak. The density of a graph is at the maximum. So complete graph is very dense. And connectivity means with connectivity equals to 1. With path length, connectivity means path length is equals to 1. Means every node is connected to every other node of a graph by a direct edge. So this density is at its peak. Five more minutes. Euler graph and Hamiltonian graph. So Euler graph are the graph if we have to travel each edge exactly once. Okay, and if there's a restriction that we'll have to come up to the same starting point, then we call it as the Euler cycle. If not, then Euler path. Same is the case Hamiltonian graph. A graph is said to be Hamiltonian graph if we can traverse the whole graph just by traversing the every node exactly once. Okay. Now, if there's a restriction that we'll have to come up to the starting node, then we call it as Hamiltonian cycle, or else it will be a Hamiltonian path. Okay. So Euler graph and Hamiltonian graph. I think 5 minutes are left. I should not continue. I should not start with this isomorphism. Okay, I'll skip this as of now, and I will take, because it requires around 10 minutes to explain the isomorphism. So I'm skipping this isomorphism. I'll explain what is a planar and non-planar graph. A graph is said to be planar if I can draw the graph on a plain paper without crossing over of edges. Okay. So why? So suppose, for example, if you might have seen in your childhood that you are given with two set of points A and B, and you are asked to connect the nodes from one set to another set such that there is no crossover. So if somehow you are able to construct these type of connectivity, then those two graphs are called as planar graph. And ABC are also connected together. Suppose, for example, this one. Okay. So where it is being used? It is being used for circuit design. PCBs, semiconductor devices, semiconductor chip creation. So if we are given with certain components and those components need to be installed on a PCB, printed circuit board, such that there is no crossover. So that means that circuit is feasible because the graph is planar. Okay. So that is what we call it as planar graph, and the negation will be called as non-planar. Means at least there will be one edge crossover, at least one edge which is crossing over. Okay, how much time do I have? 3 more minutes. Okay. Now, cut set and cut vertex. Edge is said to be, I'll repeat the definition. Edge in a graph is said to be a cut set if we remove those set of edges, the graph is disconnected into at least two parts. So that set of edges will be called as cut set. Means we are given with a graph, we remove certain edges from a graph, okay, and in an intention to make the graph disconnected. So that set of edges will be called as cut set. Same is the case, vertex cut set. Vertex cut set means if we remove those vertices along with the edges, okay, so if you're removing the vertex, then automatically the edges associated with those vertex will also be removed. So if by removing certain vertices and their corresponding edges, the graph become disconnected. So that set of vertex will be called as vertex cut. Okay, so edge cut or vertex cut means somehow we are making our graph disconnected. Okay, ultimately what we are identifying the weak points in a graph. So if we have a cut set or a cut vertex in a graph, that means this is the weakest point in a graph in terms of connectivity. With respect to connectivity. So it can be identified in two ways, either in a max flow algorithm or in a min cut algorithm. So this can be considered as your homework. You can go through the Wikipedia, you can go through Google to identify what is max flow and min cut problems. Okay. Definitely whenever this problem will arise, we will discuss. Okay, but it is for you as a homework. Please come and read. Sorry, please come after reading about max flow and min cut. Last definition, last minute. Please allow me 2 minutes. Okay, let's not make it. Let me skip it. Okay, but I'll explain you the definition. A graph is said to be a bipartite graph if it can be divided into two set of vertices such that they are mutually exclusive and collectively exhaustive. And if and if there is one edge, then it has to be from one set to another set. Confusing. Let's remove it. Let's skip it. I will explain the isomorphism and bipartite graph in my next session. Okay. Now, why they are important? Because they will build up a concept related to the course. I will share it. Okay. So I'm stopping it as of now, as you have sessions back to back. But I think the